Hello everyone, we are going to continue the foundation engineering class. In chapter 6, I think this is the third part of this chapter. Today we are going to learn about combined footing, but different shapes. It will be the second part of this combined footing. I think last time we did combined footing, but it was rectangular shape. Okay, this time we are going for this trapezoidal combined footing. Okay, so we know already this is example photo showing the same shape. Okay, so if you look like plan view, it will be like this. You can see the shape, trapezoidal shape, and the section will be like this. So our design will be like to determine all the values here. Of course, the net pressure is needed, but we need to know what is the value of B, B1, B2, okay, and the X here, everything. But that suppose that we know the value of Q1 and Q2. It means the load from the columns coming, okay? So this trapezoidal combined footing is used when the column carrying large load and the space is not enough, okay? You have very large load coming on both, but the space is not enough. Maybe the property line is limiting the space and we cannot enter neighbor's space to build our foundation, okay? So the dimensions are selected the way that the pressure remain uniform under this, under the footing, okay? We want the uniform pressure. So you have to design, you have to choose the value of B1, B2, everything to get that uniform pressure, okay? So the size, how can we determine it then? How can we find the value of the B1 and B2, okay? So first, you need to know the net pressure, okay? You can see here Q net. That is just the bearing capacity of the ground. You can obtain the net pressure from site investigation, okay? So the lab test or like a site investigation, you can check chapter 2 of this program, foundation engineering program, and you will understand what I'm talking about. So you know it first, then of course the area will be pressure divided, the forces divided by this pressure, okay? I think I already explained here multiple times what is the meaning capital letter Q and this small letter q. Okay, this means forces in Newton or kilonewton. Okay, but this means pressure. Okay, it means for example Newton or kilonewton per square meter or something like that. Okay, so when you take Newton or kilonewton divide by this, you will get area. Okay, so you know Q1 and Q2 that can be obtained from the structural engineering part. You obtain the load coming on your foundation. Okay, and the pressure of the ground, the allowable pressure, okay, or net pressure here, allowable net pressure, this ALL mean allowable. Okay, so it means you uh, use some safety factor to reduce it, something like that. So you know this, you will get the area. That means the area that you need to support this load. Okay, and now the section we will choose to obtain this area will now be depending on the value of B1 and B2. Okay, now this is the step 1A. Okay, and of course since primary school, we know how to calculate area of this shape. Okay, this B1 plus B2 multiplied by L, okay, divided by 2. That is really basic primary school formula. Okay, so here we don't know the value of B1, we don't know B2. Remember that. Okay, and if we go for the next step will be to find the position of the resultant force so that it can be like a center line. It means finding the value of x. Okay, this resultant. So here is the equation for finding the value of x using the load Q1 and Q2. Okay, and L3. What is L3? Can you see? Can you understand the value of the meaning of L3 here? It is different from L, yeah? L3 is from center to center of the columns. From center to center, okay? So that distance should be known, okay? So from center to center, you use it to estimate the value of x, okay? That was the second step. Next step, C. Now from the property of this trapezoid, we know that the resultant column load pressure through the centroid can be obtained from this. Okay, we can obtain this equation. So x plus L2, what is L2? L2, check here, from here to here is L2. Okay, means from the center of this column to this limit. Remember that this limit is, for example, if the property line is here, is mainly determined by the property line. It means you can easily know the value of L2 because, of course, you know the dimension of the column, okay? And from this column to this limit, which should be the property line, for example, it's easy then for you to get L2, okay? It means in this equation, we have only B1, B2 that are unknown, okay? We have the other things. So, so we know the value of A, of course, we calculate it from here. We know the value of L, it is given by the the drawing on the building or even the, how to say, the imposed by the structural design, maybe. X is calculated from this equation, and L2. Then we can solve this equation. If you take this equation and maybe this one, for example, you put them together, you will have uh, two equations with two unknown. Okay, two equations with two unknown. So that can help you to find out the value of B1 and B2 easily. So with this condition, okay, for this shape, L, this distance, divided by 3, L divided by 2 should be like this value should be within inside x plus L2. So I didn't give the solution for B1 and B2 here, but you combine these two equations and you will be able to find it easily. Let's now go for this type of footing, a cantilever footing, this one, where you have a strap beam connecting two footings like this, okay, and each footing receiving column. So you have different shape or different type of straps. For example, this one, you can see it going up to the bottom of footing here, but here it only on the top. This one is only on the top. Okay, this is just section, this is plan view, section and plan view. And C is just like a connection, special one. So there are different type, okay? But the thing is, all of them are connected by this beam. Only the footing are connected using this beam, okay? So this strap beam is linking two footing, okay? And it prevents the exterior footing from extending past the property line. Supposing that this is the property line and you cannot build over, you cannot make, if it's, if you want to do normal conventional design, the size of the footing should be too large, it will enter the property line, it will cross the property line. So to avoid that, you build this. I think this was explained before. Okay, so we use it when the soil bearing capacity is high and these columns are widely spaced. The space between two columns is enough. Okay, I think that's all for this one, and next time we will go for the next step of this chapter. Thank you very much and see you.